Well, hi, good morning, and thank you for joining me in my shop. Today is the 29th day of October, and I want to thank you very much. It's something I don't do very much. I want to thank you very much for clicking the like button. The like numbers are basically the only statistic I really pay attention to, so I always like it when I see the like numbers going well. And I'd also like to make a comment about the comments on my videos. Now, I've said many times I don't read comments. Occasionally I do read some comments. And I want to thank whoever made the comment on the last video and the suggestion that I use my SDR to check and see if the local oscillator is operating in this radio, if that's really the source of the problem. It's a really good idea, but here's the problem with that idea. It didn't come out of my head. It came out of somebody else's head. You might think, so what? And you might wonder, well, doing all these videos, you get all these comments. Can't you just read the comments and get good ideas to continue the work? And I could do that, but it would undermine the primary reason I do this work, and that's to exercise my own brain. What I found years ago when I was reading all the comments and replying to nearly all of them is that it changed the nature of the whole experience in my shop here. From one of me, battling against the radio, to one of me shuffling through all kinds of comments, the bulk of which are wrong, just like the things I think of. The bulk of them are wrong at the time you think them up when you're doing this work. And I ended up in a miserable place. And I had to stop and think about what was going wrong. At the same time, American politics took a very dark turn, and suddenly comments started showing up which were actually very hateful. It's the only way I can describe them. And it quickly got to the point, because I was receiving emails from Americans also because of some comments I had made, and I almost quit YouTube completely. I can't believe how thin-skinned I was about this. I usually think of myself as a thick-skinned person, but wow. So I actually stopped posting videos for a week. So although I am reading the odd comment, I don't want to come across comments with good ideas like the one I came across last night. I'm now going to implement that guy's good idea here, but I wish it was my own good idea. And so just a little bit of an explanation, because you might wonder, why do you do all this, put these things on YouTube, and then don't read the comments about it? I mean, there's many reasons for this. I mean, the main reason is the comments are stale by the time I read them. I'm already 2 and 3 days down the road with the project, and the comments are stale. But there's many other reasons too. And the negativity which showed up on my channel for a while is gone now, as far as I know, and that's fantastic. And I sure hope that what's going on south of the border, it too shall pass. I hope. Okay, well, let's get busy here now that I've turned off half the viewers with my speech here. So I do have the SDR running. The issue here is I replaced this tube. This is the 1L6. The comment on the video was these tubes often have troubles of these sorts, where they work for a bit but then don't work on one band but don't work on another band. So I'm going to try to pick up the oscillations coming from the 1L6. Stick it on my SDR screen. We can look at it. I'm expecting when I turn this radio on, it will function, and then it will stop. Sometime later, a minute, 5 minutes, I don't know. It could be really quick though. It's possible it could be really quick. We won't even see it. I doubt that. So there's a shield on the tube, but believe it or not, just going around the shield is going to be enough. Just like that. Just want to make sure it doesn't ground out onto the radio here. My exposed clip leads. Okay, we'll swing that around. So we're going to start on the broadcast band, and I have the radio tuned to what I believe is roughly 1 million hertz. Right here. Now the million's marked there, but I think we discovered the whole radio shifted off to the side here. So I just shifted it over here. So let's suppose that I've got this actually set for the local oscillator related to tuning 1 million. That would be 1445. Okay, so I'm going to get the SDR on the screen here. So here's a look at the SDR. The radio's not operating at all, just the SDR is running here. And you see stuff on the screen here, stable stuff. What is this stuff? I don't know. I don't know, but look, there's something sitting right at 455, or at least it's displayed on the screen here. I'm going to fiddle with the antenna a little bit, or the pickup coil. You can see me touching it, and some small changes in the signal there. So those things are inherent in the SDR. Maybe my SDR, maybe it's time for a better SDR. This is one of the very early ones that came out very early on. I am going to disconnect the antenna entirely from the SDR. So the SDR has no antenna connected to it. Look what's on the screen. So the best I can say is ignore that stuff. It's not real. Let's turn the speaker on because I've got this tuned right here. What do we hear? And if I move it, there's a little bit of a change. So SDR thinks it's got something there, but there's nothing there. So when I turn on the radio, which I believe is tuned for 1,000,000, we should find the local oscillator happening right in this area here, for crying out loud. Let's do this differently. I'm going to take this down. I'm going to tune in around 800. Then we would find the SDR or the radio local oscillator somewhere here. So I'm just going to tune the radio down to where I think 800 is. Okay, so that'll land the local oscillator in this area somewhere. Great. Okay, that's kind of an interesting display on your screen, isn't it? Kind of the old and the new. Okay. Plug in the radio here. Now, is there anything I'm forgetting? Am I forgetting anything? We're definitely on the broadcast band here. No, I don't think I am. The power's off right now, so the switch is off. Okay. Power is on. Whoops. Flip this switch. We got to watch that SDR right away. And some other stuff may show up too. Other weird things may show up. I don't know. Let's see. Here we go. Okay, so there's the local oscillator. A little too much volume. There you can see it changing. Oh, there we go. That's a little better. Just keep your eye on, don't get distracted, Jim. Keep your eye on the local oscillator. So, I'm just going to leave it alone. You will see my SDR is running very slowly here. If we take a note of this, it's at minus 35 dBFS, whatever that is. So 35 right now. Okay, radio, do your thing. Like, do away with your thing. Do something. I'm going to sit here for 10 minutes and wait for this to happen. Yeah, that's what could happen. Maybe stand here for 10 minutes. Well, it's been 5 minutes now and nothing has happened at all. It's still at minus 35 signal strength. Okay, we'll give it some more time. So it's been nearly 10 minutes here. Whoops. And nothing's happened at all. The local oscillator strength has remained at minus 35. So what I've decided to do now is I'm going to tune through all the different bands. We're just going to go through the process of seeing how well the radio's working. Maybe it'll quit during that process, maybe not. So let's check out this. And this interference here, this is not the radio. This is something in my house or near my house. Don't know. Lovely. Now that's me bumping the volume control here. Ooh. 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 What happened? On the volume control? Oh my gosh, the capacitor. Okay, capacitor, eh? We can do something about that. So what's probably happening is the grounding of these rotating plates is probably not good. So I'm just a sec here. That's as low as I can turn this radio. Let me tune it off here. It's quiet right now because it's actually not working. So is this really the problem? Yesterday it was kind of like a slow fade out. This is going to be more like a sudden thing. So the grounding is done with these brass spring-loaded pieces that are pushed down here. You kind of see them there. And these brass pieces are pushing out against this brass, what I think is brass, flange here. And that's the ground. And there's some others in here too maybe, but we're just going to put a little bit of there we go. I do not like this stuff. I do not like it. Okay, I'm going to try to rapidly tune. Oh, jeepers. The better move would be to turn it off, but I don't want to do that. Oh, it's getting louder as I get to this volume control. Okay, just letting the SDR catch up. And right up to 35 again. So, pretty clear this band's working fine. We're 15 minutes into the test. The local oscillator has not quit. The radio has not quit.
He's showing that he can play the right side this year. He's being able to, as you said, jump up in the right, also play on the
Oh, something more going on. So another possibility is plates are in contact with each other. They're rubbing. They're touching. Where'd you go, radio? Is the local oscillator jumping on and off when it does that? Trying to get it to quit here.
looked.
There. And the local... oh, no, this is still working.
People think they have it, but...
So the local oscillator is... Ooh. Oh, that's me tuning it. The SDR is reacting very slowly. In fact, it's kind of annoying. I'm going to speed it up. Here. It'll be a little more close to what's actually happening. So the local oscillator is not disappearing. It's not jumping around.
Yeah, I'm nice here and healthy.
Yeah. The volume control is jumping around. So one of these three is the oscillator control. And without looking, let's see if we can figure out which one it is. I'm reaching down to touch the stator plates here. This one retunes the radio. This is the oscillator. These ones just make it weaker. add some noise. This guy retunes. So this is the oscillator. This one's not in trouble, because if it was, when we tuned, the local oscillator would jump around on the SDR. I see a plate that's pinched in already, right here. This plate is pinched in. Let's look close. Let's, no, let's not. Too much of a hassle for me here. So I'm just going to bend that plate out a little bit. I'm going to short it and see if the radio goes quiet too. Yeah, I'm pretty sure it's this plate here. Let's see.
Find out.
That was easy. Oh, not so easy. Who's doing that? Shouldn't use a metal. Not that one. Okay. More volume. I think it's this outside plate here. Yeah, these don't like bending.
And to be honest,
Well, you can't see it with your eyes, but the second plate in on here is bent this way a little bit for some unknown reason, and it's bringing it into contact with the outside plate. And pretty tough to bend these. These are stator plates. There. And I'm going to bend the outside one away. These plates are very close as capacitors go. And they do not like bending. Let's try that. Could this have been what was happening yesterday?
capitalize on the
Maybe this is all it was. And you can actually see that this second plate is in a little bit. I'm not sure what would have happened there. Okay, we got that done. It's now been what? 20, more than 20 minutes this radio's been operating. And okay, let's do the band. Let's do the band thing. Let's do the band thing. So we will go up. This is not showing the truth here. So we are now on the 11. We're on the 25 meter band. 11 megahertz. Should be stuff here. And antenna is connected. Is it not? Yes. Antenna is connected. Nothing. This is not a friendly radio to tune. You gotta do a lot of this to get it to go anywhere. Nothing, eh? I kind of thought it was handy to put the volume control here because your hand is here, and while you're tuning you need to adjust the volume. I'm usually doing the two-hand thing on radios when I'm, searching around or doing the shortwave deal. Now I think having this here is a bit of a problem because if it's not getting caught, I'm bumping it with my hand. Nothing on this band at all. That's a little hard to believe. Maybe the band switch hasn't connected properly, so I'm going to wiggle it a bit. No, doesn't sound any different. Okay, we'll go up to the next band. Next band. So we're at 8 megahertz to 4. Should find something up in this area. Nothing again. Oh.
From Jerusalem, later from Israel,
Bingo.
the gospel message was carried with them to many foreign lands. This diaspora was a partial...
Okay, something's definitely wrong here. This signal we're listening to is almost certainly 9.3 megahertz on this band up here. Maybe not, but it's certainly not. Like, what's the band indicator is not correct here. Oh, for crying out loud, I am on this band. What happened? I guess the band indicator is sticking and I'm getting fooled. How did we get all the way up there? So this band's working anyway, the 31 meter band, and the sound of the radio is nice.
Is at the end of the world, but this was a partial fulfillment, just as it was less than 40 years later when Jerusalem was destroyed. Okay, moving on then, in verse 26, what does it mean?
Yeah, we're moving on. We're moving on. So that band's working. So let me see if I can't figure out how to operate this radio. So now we've gone up to band number 3, 17 megahertz. Well, there might be stuff up here. A little early in the morning for it, but I keep getting excited. I think I'm tuning something in, but it's just the volume control creeping up. Nobody home up here. It sounds like it's working though. Okay, let's go another band here. Down. This will be band number 2. 1450 to 1550 roughly. Should get stuff here for sure.
Yes, you're omniscient. Yes, you are omnipotent. Yes, you're omnipresent. But you're my Father. Because I've been born again, you've adopted me into your family. I'm your child.
Hear that thud, thud? Ooh, what's that? So that's a signal being picked up, that da 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 thing. But this pop, I don't know what that is. What's this? Another weird sound. Okay, no idea what that is. Is that here in my shop? So where are we? We're around 15.5, somewhere around there. This is not the best radio to hunt for stuff. 15.5, because that was a sharp, narrow band signal. Oh. That battery quit on my radio. Okay, pretty sure that sound is for real. That's really something here in my shop, or it's transmitting this sound, I believe. Oh my gosh. Wow. Okay, so well, that's clearly WWV. That should be heard here, not here. So the alignment is way out on this radio. Again, same thing every time. clock. Oh, too late on the clock. My clock's not that accurate. Okay, so we go up to the next band. The next band up is a long wave band. This radio has not faded out at all the whole time I've been doing this. There's really no use in doing the top band, except we gotta hear it. We gotta hear that it's working. We have to this way. This doesn't want to show band number 1. Why would you not want to do that? Fairly complicated deal in here with this sliding piece. Don't know what's going on there. Okay, so the whole time I've been doing this, I've been waiting for the radio to quit completely. It has not. 9. Okay, so this is 4 out to 8. Might get something here. Way up here. No, nothing there, but it appears to be working. Again, there's just nothing to receive. And over the next band. It went up, down, down. Okay, so now I'm on the 11 band, the one I thought I was on at the start. 11 megahertz. Volume control. Oh, volume control's in a bit of trouble too. Here. Something funny going on there. Something funny going on. That wasn't just dirt, I don't think. It's okay now. And we're not going to hear anything here. Okay, this is the automatic volume control on this radio. That's what it is. Well, okay, give it a long time now, half an hour of operation. It never faded out once. So whatever the fading problem was, it has faded away. The fading problem has faded away. And until it reoccurs, you can't do anything because there's nothing to do anything about. So I think we're looking at cleaning the volume control here. I'm going to turn it off. I'm going to clean up the volume control, which is over here. And chassis is quite warm in this corner. Is it coming from this resistor? Coming from this thing? No? Ooh. So this guy's hot, this guy's hot. This guy's really hot. There's some problems there. Okay, I'm gonna stop for a little bit and have some coffee. Okay, I've come across something a little bit surprising. I was getting ready to spray the volume control. Hey, where is the volume control? It's up here. It's in this little box. Can you see there's an opening here in the chassis? The volume control is in there. And if you look up on top of the chassis, it's in a cardboard box lined with asbestos. What the heck is going on? They put the volume control in a cardboard box lined with asbestos. what is it about this volume control that they think it's going to explode or something? Is it not asbestos? So we're going to look with the close-up camera. I'm pretty sure it is, but let's take a look and see what's up. So there's the volume control. It's getting ready to spray in there, and for sure that's got to be asbestos. Asbestos lined cardboard box. This just doesn't make any sense. Protect. Oh, wait a minute. Wait a minute. Wait a minute. The on-off switch is behind there. Maybe that's what they're after. All tucked up in there. But really, asbestos around an on-off switch? Why? Like, they must have had a radio where the on-off switch failed and the on-off switch set a fire. And their way to solve it is to stick it in a box made of cardboard. What? And line it with asbestos? That doesn't make any sense at all. When things don't make sense to me, and I know smart people are involved, I quickly reach the conclusion I just don't know something. There's something more here I don't know about. And I should just leave it at that. This wasn't done by, for a stupid reason. This costs money to do this. Well, okay, I'm going to go ahead and do the cleaning thing here. Fortunately, it's perfect for doing it. Yikes. One of the reasons I don't like this fluid is you can never see what's come out. Okay, so I'm just rotating the volume control here a few times. The other asbestos sheet really has me wondering too. Is it so if it's the power problem, something to do with the power coming in on the line, what's going on over here that they need that asbestos sheet? And the answer is I don't know. Okay, well, we've got the radio tipped up. Let's take a look at this tuner, because the last time I looked at it, it was rotated around the other way. You couldn't see inside. Now we can see the different sections. You can see the coils, and as you switch bands, these coils are rotating in. Look, there's a bunch of adjustments here that would only be exposed when a certain band is operating. Probably the one that's operating right now. Could be some more adjustments in here. Sometimes there can be capacitors on these pieces. In my Hammerland radio has a huge one of these things, and it has a lot of components inside the tumbler that need to be changed. Okay, what to do now? Well, we know the pointer's in the wrong spot. And from there, if anybody tried to align this radio with the pointer way off in the wrong spot, then the whole alignment is messed up. Maybe what we should take a look at first is the IF alignment and see if it isn't close. Should I leave this like this? I think I have to, because if I want to do IF alignment, I got to get at these things here from underneath. So I'm going to leave it like this. Yeah. Let's skip to checking the alignment. I don't want to replace any of these parts yet. Could the alignment be off because of one of these parts? Not the pointer. Not the pointer. Actually, having a little bit of coffee made me rethink things a bit. There's still some questions here that need to be answered. And one of them is, what is going on here with this silicon diode located there, the original rectifier here, this probably added in resistor here. This resistor is, let's use this camera here. I don't have to strain my eyes then to see it. This way, should be this way. I think it's 0.1. 5.1. 5.1. So they have a 5 ohm resistor. So what people are often concerned about is these rectifiers run with a bit of a voltage drop, And when you change these to silicon diode, the voltage drop is much lower. It's 0.7 or so. And so the excess voltage then carries on into the radio. So people will put in a resistor to knock off the excess voltage. I personally think it's probably not needed, but there it is. Now also, normally if you're going to replace this with one of these, then you're going to cut the lead off. How come this is still in the circuit? Now maybe this is open circuited and it's no longer a concern, but I don't know. How can I know that? It doesn't look right to me. It looks like that top terminal should be knocked off, should be cut. This one here should be cut, or the connection should be made some other way or some other place. Let's look at the schematic and just see if this is on the schematic, which I doubt very much, but let us have a look at it. I guess at this point we're forced to study the way this heater string has been done and the power supply that's supplying the B plus into the radio. And we're looking for a 5.1 ohm resistor, and I can tell you now I don't find it in here. So we're coming in from the power cord and we're going into this thing, ballast adapter socket. Oh, there goes my phone. That was an interruption by the grocery store. Okay, so I think I was just talking about this ballast adapter socket. I don't know where this is in the radio, and this is a piece, an adapter, and it says accessory ballast adapter. Don't know what this is all about. I don't think it's in my radio. I don't really know what's going on with this. So we'll assume that this is not existing, and you can see the way they have this arranged. It just goes through like it's not there at all. So we come to what I think is the on-off switch. No, this is the switch that is operated if you want to operate on battery, and you push the plug into the spot here on the chassis. It will operate this switch and switch everything around. So power goes this way. We encounter the first resistor, 82 ohms, 2 watts. So I have to look for that guy. Then we have a small capacitor, and then we have the rectifier. SR1. SR. Silicon rectifier 1. SR. So from there we reach a large capacitor, and it says 100. Oh, that's the rating, but the voltage here is going to be 130 or something in that range, I would think. And then we go through a 2000 ohm 10 watt resistor. So we're going 150 volts here. On the other side we're way down to 9 volts. So this guy's dropping a lot here, just throwing it away. And then we have these very low voltage tubes. I guess the trick here is how do you supply low voltage tubes, which are designed to be supplied from a low voltage battery, when you want to plug it in this high voltage thing. You've got to get rid of the voltage somewhere, so it's here. And I'm sure that's that big resistor that's just sticking right out in this radio. I also see a large resistor right next to it, and it could be this guy. So we'll go a little further. Here's another resistor, a 3000. Where's the 5 ohm or 5.1 resistor? You don't see one in here. Don't really know for sure what, this must be the original rectifier that's been replaced with a silicon diode. Nothing spectacular going on here. Why didn't the guy cut away the old one? Maybe it's the case it just doesn't matter if it's sitting there, even if it is like these old original rectifiers. They tend to get hot and they drop a bit of voltage at the same time, of course. What to do about that resistor? What to do about, where's this one? Let's find this one, measure it, and we'll find this one. It's easy. We'll measure that, just see what these are. Two critical resistors in the scheme of things. Let's go check them out. Okay, two critical resistors. Well, right up here, I'm sure this is the big 10 water, and right below it. Now that looks like red, red, red. So that'd be 2200 ohms. I wonder if what happened if this burned out and this is a replacement, and that's the best he could do is 5.1 ohms. But on the schematic, let me just peek myself, we really should see an 82 ohm resistor. This is a head. Where's the power cord? Where is the power cord? Oh my gosh. I don't know where the power cord is. Oh my gosh. It's going to be dealing with that switch on the back of the volume control. Where's the cord even coming in? It's coming in right in this corner. Here it is, right here. Coming in right here. And coming down. Going in behind this thing. Oh, I know what this is finally. I've been wondering, what is this? This is the switch that operates when you want to run batteries and you shove the plug into the top here. It's got a spot to shove the plug. Where's the spot? There's the spot behind these wires. You shove the plug in there and you operate this switch here. This thing. So this will clearly have the power coming to it and leaving it. Yeah, here's these big resistors. There's a 3.3K resistor right there. Yeah, I don't know how I would ever sort this out exactly. This would take a long time. I'm concerned about nothing. I'm concerned about nothing. I just want to understand what's going on. I can always assume that whoever did this knew what they were doing. Where's that 82? So the 82 would be gray. Ooh, that's it there. Gray, red, brown. That little guy. I got my color code right. Gray, red, brown. Gray. So just put any one of these to a gray color. This is what happens when my brain really slows down. Is there not a gray? Well, I thought it was 8. 6, 7, 8. Well, that's gray. It looks black to me. But that supposedly is gray. 8 is gray. So gray, red, 82. There it is. What's it doing on the volume control? So that terminal of the volume control is quite likely a B minus terminal. Oh my gosh, I don't know. This radio works. What am I doing? I just pack it in, man. You're done. You don't have to do anything to it. No, we have to align it. Well, okay, I've taken a look at this. Don't know what's going on. I've taken a look at this. Not sure what to do about it anyway. Looked at this resistor. Don't know why it's there, but it's there. And the radio's operating, and assumably somebody did it for a good reason. And we can't find the 82, although maybe that's it, but it doesn't seem to make sense to me. And what's this? There's a high wattage 222 here. Does it look replaced? No, it looks original. Very much so. Well, let's find the 222. And I'm sure the 82 was a higher wattage resistor. That resistor looks a little different than the rest. It looks a little more beat up than the rest of them. They look fairly new. This one looks like it's been rolling around in somebody's junk box for a few years. So I wonder if that's the 82 replaced with 22. I don't know. How can I sort this out exactly? figure this out. See, they're hooked up to the switch there, and then trying to sort out the switch is suicide. Oh, it's going over here. It's going to ground. Well, that's the... No. Not going. Yes, it is. They're all going to ground there. So they're not going to the chassis. They're going to the B- terminal, and that's an isolated filter capacitor there. Sorry, just thinking to myself for a moment. Okay, yeah, I'm kind of lost here. Let me stop for a minute. Okay, so I think I've got this switch arrangement figured out here. First thing that came clear to me is there's two switches involved here. See the dashed line, large dashes? And this goes up to the volume control, so this is the on-off switch here. This and this. And it's showing switched off right now. And when it switches on, these two switches close. They then get the feed, if you like, either from here or from here. And same thing here, either from here or from here. So if we follow this from the plug, you see the current situation is the plug is selected on the power selector switch and the radio is turned off right now. That's what's going on here. Wow, this took me a while to sort this out. Simple one, you know, like a lot of things, you know, when you get it, you go, wow, that's really simple. Why did it take me so long? And I don't know what the answer to that question is. So now, so this switch is shown in the plug position, if you like, and sure enough, it's getting a B plus from here, going through the 2.2 1-watt resistor. That's the one that I'm curious about, and then on its way. So we want to measure this for sure, just to make sure it does look a little beat up. Okay, we can do that. This, I think we can do that. Yep. Okay, let's do that. Do I have any real reason to think it's wrong or the value is off? Only because it's been working hard. I don't have any real observation that suggests it, but let's check it out. So it's at least 2.7. And there could be parallel paths. This resistor could be higher yet. 2.2, 2.7. Wow, that's a variation. Let's try this big one here. (2,000 ohms). Does anybody remember what it was on the schematic? I am looking. It's a 2,000 ohm resistor, so that guy's held in fine. Often these wire wound resistors are really rugged, and they can take it. Now, just below here is a 3.3K resistor. Ooh. So this is probably a parallel path reading problem, because resistors generally don't go low. That's not been my experience. This is supposed to be 3.3 on there, not 0.06. That would be bad news, I think, if it were actually that low. So I'm thinking about, should I operate the switch, putting the plug in, and then measure that again on the basis that this is no longer in a circuit? Why don't we try it? What have we got to lose? I'll operate the switch, and the switch fail, and the radio shot. There we go. Okay, so plug is in. I don't know that this is going to make any difference, but 3.3. So we got a little high, but that's not enough to worry about. And we'll try this one again. This is supposed to be a 2.2, 2.7. It's right in line with the B plus traveling into the radio. So a little extra voltage drop here, a little less voltage at the tubes to operate. How much different would it be? Well, that's right on the edge of, it'd be wise to change this. It's right on the edge of that. The other thing is, this is a, so is this one. These are both wire resistors. Now, with this one sitting here, I guess it's not a problem, but in some radios, if you're going to put in a resistor, you're going to pick a wire or resistor, you're going to get into trouble because the wire is a coil. You can't just whip these in anywhere, as I have done in the past. I don't do anymore. Yeah, I'm going to stop and think a little bit about this. Okay, here's an idea. Why don't we check the voltage on the far side of that resistor and see what's happened. So the resistor's here. So what's the voltage on this side? When we follow this along, I've already done this, so I know where the answer is. Come up here, 95 volts. That's what we should find right here. I'm going to measure it, 95 volts. Okay, I think I'm all set to go here. I've clipped in the voltmeter on one side of the resistor, and this is a B minus terminal here. I determined by tracing a wire from the capacitor frame, the filter capacitor can, if you like, which is isolated from the chassis. The chassis is not at B minus in this radio. Good. So I think we're ready to go. I got this set on 600 volt scale, and we're looking for 95 volts. Any reason why would I hesitate any further? I don't know the radio's turned on. Let's just make sure it's turned on. Yes, turned on. Volume up just a little bit. Okay, we're ready. There we go. You gotta plug these things in, This is, I've got it plugged in here. Okay, this time it's gonna go. Here we go. This is supposed to be low, not high. Well, there certainly isn't a problem with lack of voltage here. So chances are this guy is supposed to be knocking down the voltage. This is the one that does not appear on the schematic. What was that? Anything happened there? Radio went quiet. Did the radio go quiet? That's the tuning. It appears to have gone quiet. Okay, we're not going to sweat over that situation. Turn off the power. Well, okay, so if I were to reduce this to what it should be, there'd be even more voltage over there. 95, 120. Is 120 a problem? I don't think so offhand. I mean, there is a limit here. I'm sure it can go a lot higher than that. Let's just pick any one tube. Well, we'll use the output tube, 3V4. So we'll look up a 3V4 here. 3. I need to practice the alphabet more. There we have 3V4. Hey, it's circle. $1.50. Yeah. What do we want to read here? We want to read the plate voltages. So, typical operation, plate voltage 90, 85, and 90. Plate voltage 90 max. Ooh, sorry, you can't see my book here. 90 max. We're at 100 and something. Wow, that's really low. Maybe it's because these tubes are very small, and you know, the elements are packed together very tight, and so they can't sustain much voltage. Wow, that's so surprising to me. Is this a problem? Do I have to deal with this? Just leave the dim bulbs in all the time? Put a big dim bulb, just put a big light bulb on the radio to cut down the incoming power. That's probably what this guy's trying to do. Could something else be causing the high voltage? What were we running it at? Let me unplug it. Maybe I booped up here. I'm running it too high. It's possible. 118. So I had at least 100. It had no more than 118 volts on it. That's certainly within the range of an outlet. I gotta stop and think again. Well, after giving it some thought, I've decided to return to the alignment issue and let the radio be as it is right now. And the first step in the alignment is to get this pointer corrected. And I've got to assume the pointer should line up on these dots here at this end. So we're gonna push it there. Make sure the capacitor is completely closed. So the pointer should be over yonder. You can see the scratch marks where it once traveled. How did it get off center? I don't know. So someone has, rather than just rely on the string going through here, they've done this wrong here. But they've gone and stuck some tape in here. Now is that going to stop me from moving the pointer? So as I've explained numerous times, but I will explain again. Counterintuitively, if you want to push the pointer this way on the string and you hold the string here, you're going to have a hard time doing it. But that's what we would normally think to do. In fact, you hold it on the side where you're heading. So I'm going to pinch it here, and what this does, see the slack develop here. Okay, so that slack will get through here, except they've gone and stuck all this tape in here. They're doggone it. I don't think it's moving at all. Drat. Why did they do that? I pull it out. Like anytime you deal with a string, okay, it's high tension. If you break the string, you got a lot more work ahead of you. The string, they appear to be in great shape in this radio, so I'm not too worried about that. To pop this out, get rid of this tape, and when I fish the string back in, I wrap it the proper way instead of the way they've done it. Is this glued also? Did they glue this in here? Yeah. But the glue didn't hold. So we're gonna slide this right out, and then I'm gonna push this down to roughly where it should be. And we're just gonna lay the string in there for now. Take a look at the situation. We're not there yet. It should be right here. This is the spot. Making sure the capacitor is still at max. That's where it should be. So we'll see if we can put the string in properly here. So we would come. It proper way does not look proper. Twang. It's going to break right now. It's like trying to fish this between knife edges here. Ooh, this is not going well. Jim, we're going to cut it right there. I see why the guy taped it. do this in the middle better, where the string is a little looser. Do it in the middle and then set the close the capacitor. Yeah, let's do that. I'm going to dial this over towards the middle here. Could have marked the string if I was smart, but you know, not smart. Okay. I gotta break it. You're gonna break it, Jimmy. You're gonna break it. Okay, the other way is to stick it in the way it was and bend this tab, which is that's probably a better move. Bend these tabs a little bit. Doesn't take much to hold the pointer. Put this back here. Now we'll move this. Now what happens to that tape when we get way down here? Does it come up on this wheel? Oh, this is a tiring radio to tune. Holy smokes. Wow. It's the end. Oh, how can that be the end? It's not the end. What happened? What's so now we know why the pointer was set off. Because for some reason you can't. Well, that doesn't make sense. Well, what happened here? Something is stopping it. What is stopping it? Huh. Oh, that's weird. Okay. So if we look down here, never seen this before. See this peg sticking out of the big plate here. This peg? The peg is striking this piece of metal here on the frame and coming to a halt. Let me demonstrate. Why would that be? Why do you want this wheel to stop? Isn't this just a wheel of nothing? There's nothing hooked up to it. Well, there is actually. So they have a string to move the pointer. Oh my gosh, this is a complicated radio. They have a string moving the pointer. They have a separate string doing the tuning here. So what's happened here is the pointer string. So we're at a limit, but we're not at a limit here. So somehow this and this have gotten out of coordination. This doesn't do anything, but except it's driving the other. Oh man, I gotta stop and think about this. Wow. Okay. What a puzzle. Why wouldn't I slip the string on the wheel here? We slip the string on the wheel, keep moving till the pointer goes where it's supposed to and the capacitor closes, and then we stop slipping the string, it'll grip again. How are you going to slip the string on there? It's a similar fashion to slipping it through here. So you want to hold it on the side where the tension will release. Does that make sense? So where would that be? So we want to go this way further. We want to go this way further. So I would want to hold this string down here. This one here. Don't shove it through the speaker, Jim, there. and we try to hold it. You know, it goes around this wheel like 3 times, for crying out loud. For crying out loud. That's a phrase I learned from my parents. So it has one string going around the dial, and that's the string that's driving the big wheel. And then the small wheel, you have some trouble seeing it down in here, that's driving this, is driven off this. So how's that help? That doesn't help. How's that help? So should I do this the other way? I move it all the other way and try to slip something. Now the last guy gave up on this. He just moved the pointer. Good enough. Well, I don't know. I could stand here in silence for a while, but I'm not going to. Okay, well, in fact, I just got back from the grocery store here. It's gotten a little late to continue, so I'm going to stop at this point. And tomorrow, I don't know. I have to figure out what to do about the string there, because yeah, you work on these radios. You never know what kind of challenge is going to come. So thanks a lot for watching today, and hopefully we'll make some more progress tomorrow. See ya.